Welcome to AP Calculus and finding the derivative of exponentials. Just as a quick review, looking over your properties is going to be beneficial to you because as with logarithms, using those properties made finding the derivatives in smaller pieces made it a little bit easier. So using these properties of exponents, we're going to do the same. Plus, it just never hurts. Now, when you're finding the derivative of an exponential, it's super easy. In fact, sometimes it's like creepy easy. When you are finding the derivative of an exponential, you are going to rewrite the exponential as is, don't change a thing, and then you're going to multiply it by the derivative of that exponent. So every exponential is in essence like a chain rule. So looking at example 1 here, if I take the derivative of e to the 2x minus 1, I rewrite the exponential, e to the 2x minus 1, and I multiply by the derivative of the exponent. Seems pretty nice. If your base is not e, just like with your log, that isn't a base e, we start off with the natural log of the base we do have times the exponential as is times the derivative of the exponent. So looking at example 2 here, when I take the derivative of 3 to the x squared, I'm going to start off with the natural log of 3 times that exponential as is times the derivative of the exponent. So the derivative of x squared is 2x. Now when I rewrite this, I can rewrite it in any order I want to. I can do the 2x natural log of 3 times 3 to the x squared. Just make sure you're not multiplying your bases together because remember your order of operations. Exponents come before multiplication, so I would have to know what 3 to the x squared is equal to before I could multiply it by the 2. So just be careful. We also, just like before, would have a product rule here on number 3 as an example, taking the derivative of the first times the second as is, plus the derivative of the second times the first as is. So that's what number 3 is all about. So let's look at some additional questions. Now looking at these problems, always see if you can simplify this a little bit. When I look at it at first, it looks like a quotient rule, but really if I just divide both of those, that's 1/2 e to the x minus 1/2 e to the negative x. Well, that problem's not very hard at all. You've got two exponentials, and those exponentials have a base of e. This one's really pretty nice. So when I take the derivative, that coefficient's along for the ride. I have e to the x, rewrite it, then multiply by the derivative of the exponent. Next term, minus 1/2 e to the negative x, rewrite your exponent, then multiply by the derivative of the exponent, which would be -1. If I want to simplify that some more, I've got 1/2 e to the x. I've got plus 1/2 e to the negative x. And then, of course, you can rewrite that with the exponent being positive. They gave us the problem with the negative exponent, so we can give it back to them. But in case you would like to fix that exponent, that is what it would look like. Not too bad. Final answer. Now, number 5 is a little healthier, shall we say. We've got an implicit equation, so we will have to do implicit differentiation, and watch your parentheses. Some of you act like you're being charged for them. Use them freely, please. So, for instance, when I'm taking the derivative of e to the xy, I'm going to rewrite my exponential, and then I will multiply by the derivative of my exponent. Well, the derivative of xy is a product rule. The derivative of x is 1 times y as is, plus the derivative of y, which is dy over dx, times x as is. Parentheses because you're taking both of these terms times e to the xy. The derivative of x squared is 2x. The derivative of negative y squared is -2y dy over dx. That's all going to equal the derivative of 10, which is 0. I need to distribute this through so that I can get my dy dx terms on one side, my non-dy dx terms to the other side. So e to the xy times y is y e to the xy. dy dx x times e to the xy is x e to the xy. I know some of you can't believe I didn't get tongue-tied, and honest, I didn't redo the video, so maybe I'm getting better. Probably not. Don't expect it. All right, so I've got my dy dx terms where I want them. I'm going to go ahead and subtract that y e to the xy, and I'm going to subtract the 2x. So subtract those from both sides. Okay, so now if I factor out my dy over dx, I'll have x e to the xy minus 2y. Did a little multitasking there. Think about it. So once I pull the non-dy dx terms to the right side, both of the terms that were left had a dy dx involved, so I just went ahead and factored that out all at the same time. And then I'm going to divide. So I end up with negative y e to the xy minus 2x all over x e to the xy minus 2y. Now if you decided to take your dy dx's to the right side, you are going to have the same answer, only you will have all positives on top. Your x e to the xy will be negative and your 2y will be positive. So if your signs are exactly the opposite as mine, you're perfectly fine. Don't panic. I know some of you love to panic. All right, number 6, sorry. Saw the 8, got all excited. Now this is one of those problems where you will want to simplify. If you have the same base, you can simplify. If you have the same power, you can also simplify. This one kind of goes both ways. I'm going to do it this way. So I'm going to go ahead and take the 4 and the 8. Okay. So because they had the same power, I'm going to simplify this way. Well, 4 divided by 8 is 1/2. And I'm going to treat this as my exponential. So my base is 1/2. Not a problem. When I take the derivative, I'm going to start off with the natural log of 1/2. And then I'm going to multiply that by my exponential, as is. And then multiply that by the derivative of my exponential, which would be 1. This is where they might do some fancy simplification. Sometimes people don't like fractions. Now, we love fractions, but that's just us. But other people, not so fraction friendly, so they may do a little manipulation here. When I'm looking at the logarithm, this guy right here, I can bring that 2 up, and it's just going to cost me a negative power, -1 power. Well, with logs, if I have a power, I can bring that down in front. So now I can switch this to -1 natural log of 2. Now the rest of it, I would get a negative exponent, and the negative exponent they're not really willing to have instead of the fraction. They'd like the fraction better than the negative exponent. So this may be the answer that you see. So be looking for ways that we can simplify those exponentials, those logarithms. Just look for opportunities to simplify all the way around. Now, we've looked at how logs help us differentiate problems that are really, really big and nasty. So if you remember from the last section, we had a problem that had a 3-way product rule with a chain rule and a quotient rule. We used logs to help us differentiate that more easily. Well, in a case like number 7, it's the only way that we can differentiate this. If you look at what they gave us, we have too many variables in too many places. We have a base that's a variable. We have a power that's a variable. If you remember, we only know how to do the power rule. So for instance, that's where the base is a variable, but the power is not. And we now know how to do exponentials, where the base is a number and the power is a variable. When we've got a variable in both positions, we got ourselves some trouble. So what we're going to do is we are going to natural log both sides. So if I natural log both sides, I've got my y here, I've got my x sine of x. just like what we did before with the chain rule, my power can come down in front. Now I have a little bit nicer of a problem. Natural log of y equals sine of x times natural log of x. I've created a product rule with a nice little trig function and a nice little logarithmic function. Now I did once again change my problem from explicit to implicit, which means we will have to fix that in a moment. When I take the derivative of the natural log of y, I take 1 over what I'm taking the log of times the derivative of what I'm taking the log of equals. We have a product rule, so the derivative of the first guy, let's bust out the colored pens here. Derivative of the first guy times the second guy as is, plus the derivative of the second guy, 1 over what you're taking the log of, times the derivative of what you're taking the log of, times the first guy. When I look to see if there's anything I can simplify, there's just not a lot I can simplify. I have my cosine of x times natural log of x. I have my sine over x. I do need to solve for my dy over dx, so I'm going to multiply both sides by y. When I multiply both sides by y, remember those parentheses are free of charge. Put them in. Some of you, I don't know what's going on. Instead of putting the y there, remember we'd like to keep this problem in the same format as it was originally. That way we have all y's, all x's, where they're supposed to be. So notice, even though this doesn't look like it's more simplified, it is, because we have nothing but x's on the right side. What we started with was explicit. What we end up with has that same feel. Okay, the rest are examples for you. I hope you enjoy.